We're on.
Perfect.
Alrighty.
I felt like a lot of this, at least for me, it seemed like quite a bit of review.
Yeah.
There was some of it that I was kind of like, oh, I didn't. Like, when it talked about how far apart the nucleosides are, like, I didn't realize how far away the, however many nanometers or whatever it was. That was kind of cool, but for the most part, I felt like it wasn't anything too crazy.
Yeah. Yeah, I think I finished this one faster than I finished any other one, so didn't take me too long.
I do have a question on number 3 for you guys. From the answer key, I don't know where she's getting some numbers, but anyway.
Yeah, I had a question about that too. Where she got the conversions.
The 196 to 197.
Yeah.
Oh yeah. So
yeah,
I think
thought it was 146 to 147.
Yeah. So in the last sentence, it says assume the average linker length of the linker is 50 base pairs. That's just like in between the nucleosomes. So,
so you add that to it.
Yeah, exactly. Yeah, it took me a while to figure that out too.
Oh, perfect. Okay. Well, I'm signing off. Just kidding.
I can do number 1.
Okay.
Right on. So the 3 parts of a nucleotide are the base, the phosphate group, and the sugar. Is that what you guys got?
Yes.
Okay, and then the 1' carbon, that's where the nitrogenous base attaches. The 2' carbon has 2 hydrogens on it, and then the RNA has the hydroxyl and the hydrogen. So I wasn't sure really, because it wants to know function, and to me, like, I don't know what the function would be, but anyway. The 3' carbon attaches to the 5' of another nucleotide to form the chains, and the 5 is kind of the opposite of that. And I couldn't find anything on the 4' carbon. I Googled it and stuff, but...
Yeah. Same here. I just said that it was like that it attached to the 5' carbon, that it was kind of like where it branched off.
The link?
I don't know.
3' and 5'.
Oh, yeah, something like that. I don't know.
Okay.
Have you guys looked at the key?
Oh, I didn't.
The key said that it's the carbon that has the oxygen that closes the ring for the pentose sugar, which is true. The hydroxyl group on the 4' carbon is the one that makes it so it's not a linear sugar molecule, but a ring.
Makes sense.
Okay, cool.
Significance of that one.
Cool.
Cool. I can do number 2. For 2A, these are basic, just taking it from the notes. So the 4 nucleotides were, I got uracil, guanine, cytosine, and adenine for RNA. Is that what you guys got?
Yep.
Cool.
Yeah.
So I was looking, is it uridine or uracil? Because I always remember it being uracil. But in the notes, when I was reading it, it's uridine with a D and cytidine. But I think it's probably semantics. Probably doesn't matter. I was just curious if you guys had ever heard those before.
Was the dine on the nucleosides?
Yes, Dean is on the nucleosides.
Right? Well,
Dean and Sine.
Oh, gotcha.
Yeah.
And then the uridine, cytidine, guanosine, and adenosine. Those are on the those are nucleotides. Well, if you have phosphate connected to them.
Right.
The asides don't have phosphate on them, so they're just called adenosine, guanosine, uridine. And then if it's just the nitrogenous base, I think it's the uracil, cytosine, guanine, and adenine.
Right.
Who told you you'd never use that chemistry again?
Dude, I busted out my biochem book.
That's disgusting.
Came in handy, man. I know, right? Never thought I'd open it ever again.
So for B, those were the nucleosides, but those ones for DNA, they start with DO, oxy, and like. So I got deoguanosine, deoadenosine, deothymine, and deocytosine.
Yep.
Okay, for C, so we have 24% thymine, so we have to also have 24% adenine, and it's DNA, so you don't have any uracil. So then if you just take the rest and cut it in half, you get 26 cytosine and 26% guanine.
That's an MCAT question. Yep.
Nice. Good to study.
Yeah, remember
So
that.
then, so for D, the only thing that I could think of was that it was RNA. On the answer key, it says it's single-stranded RNA. So I don't know why. Do you guys know why it's single-stranded?
Because otherwise the amount of uracil and the amount of adenine would have
Would
to
have to
match.
be the same. Oh yeah, that makes sense.
Percentages would have to match. Yeah.
I gotcha.
I'm gonna go turn my light on.
Yeah, that makes sense. Sweet.
Okay,
Cool.
so I won't do 3 because I did the wrong math. So Jake, you should probably do it.
Alright, got your back. So for A, you start out with 197 million base pairs, and you're trying to find how long it is, so you take the 0.34 nanometers per base pair, so you multiply that through, and then you just convert your nanometers to meters, and then you come out with 0.067 meters.
Nice.
That's what I got.
Cool.
And then for B, like we were talking about earlier, it's the 146 to 147 per nucleosome, and then you just add in this average linker length of 50. So I did both 197 million times 1 over 196. You come out with 1,005,102 nucleosomes. And then if you just do it with 1 over 197, you get 1 million nucleosomes. So it's somewhere in between there. And then for C, the haploid human genome is 3 billion base pairs. So you take 3 billion times 1 over 197 times 8. And because that's how many histones are in each nucleosome. Then you come out with 1 million or 121 million. Then you just round it, I guess, to 1.22 times 10 to the 8th. Is that what you guys got?
I got close to that. It sounds like that should be right.
Yeah.
Okay.
If I did the 197, 196. Yeah.
Okay. Yeah. Yeah, I guess I didn't do the 196 on that one, so could be a little bit less or more than that. Then for D, let's see. We've got this is our somatic cell, so we're going to be 3 billion base pairs times 2, because everything's a diploid or whatever. So we got 6 billion times 1 over 197 times 2, and that gets you to 1 times 10 to the 7. So you guys got?
You times it by 2. You times it by 2 because the H3. There's 2 H3 histones
Right.
per
Yeah.
6 billion base pairs. There's only one. If it was just one chromosome, there'd be one H3, right, per histone.
Right.
Or I mean, one H3 histone per per 3 million base pairs. 3
Right.
billion.
Yeah.
So you know that there's two because it's just a somatic cell, a typical one.
Yeah, it's a diploid.
Yeah.
Diploid.
Diploid.
Yeah.
Okay.
Yeah, that's a tricky
Would
one.
be one if it was haploid.
Right.
Okay, sweet. For which molecules above are nitrogenous bases? So we kind of talked about this. I put guanine, uracil, and thymine. Those are the names of the nitrogenous bases. Which molecules above contain ribose? So adenosine, which is a nucleoside. Adenosine triphosphate is a nucleotide. Guanosine and uridine, which are both nucleosides. So those are the ribose. Which molecules above are nucleosides? Kind of the same thing. Adenosine, uridine, guanosine, and the deoxythymidine. I didn't put deoxythymidine on B because it's deoxy, and I didn't know if that disqualified it for the sugar. I think it does.
So the deoxy does, because it's.
I think so because a sugar has a hydroxyl group on every carbon.
Okay. I put that one with ribose, but that makes sense.
Yeah, I had a question on. I don't remember what the key was saying. Which molecules above are nucleotides? Basically all the other ones. So you got all of them that have diphosphate, triphosphate, monophosphate. If they have a phosphate in there, deoxy, or if they're nucleoside with the phosphate, then that's a nucleotide. So.
Sweet.
Cool.
5
And
was
then-
super hard.
Huh?
Just kidding. 5 was super hard.
Yeah. So the 5' end is the end of the 5' carbon on the sugar, the pentose, isn't bound, and the 3' is the 3' isn't bound. You want me to read through the complementary sequence?
Yeah, if you could do that, that'd be good.
The adenine binds with the guanine, and the threonine, or not threonine, whatever it is, tyrosine. T binds with A.
Tyrosine. Thymine.
Dude, I got so much crap going around in my brain right now, I can't keep it straight. And then for every 10 base pairs, it does 1 turn. So there was 25 base pairs, so 2.5 turns.
Nice.
Nice.
Love it, gentlemen.
Nice.
That's some real good work. So
So we got a test this weekend, right?
Yeah.
Yes.
Do it.
Saturday. Is there a ride-on on it? Anyone see? I didn't see a ride-on. Initially, I looked at it about a week ago, though, so I was wondering if she was going to add it.
I haven't
Yeah,
seen one.
I haven't seen it either.
Saw that it was 55 multiple choice still, so.
Nice.
We've done a lot of like equations, so I was surprised to not see right on.
Right.
Yeah.
pretty bummed, really. Basically 3 points, right?
Yeah.
Yeah.
Pretty much.
Alrighty. I will post the video.
Cool. Thanks, guys.
See you guys later.
Thanks, guys. Have a great night.
You too.
Yes, too.
Bye. Bye, Brad Peckers. See you guys.